So if you didn't get very far, maybe you didn't find the final answer, remember, once I start, you can always hit the pause button and go, oh, now I know what to do, and then continue on your own. That's the great thing about this. You can pause it, rewind it, do whatever you want. Okay? So first I'm going to find the points of intersection. So I'm going to set these two things equal to each other. 1/2 x minus 1 equals 3 minus x squared. So I don't really like fractions, so what I'm going to do is I'm going to multiply everything by 2. And so what I'll get is x minus 2 equals 6 minus 2x squared. Now I want to set the whole thing equal to 0, and I really want the x squared term to be positive, so I'm going to move everything over to the left side. So I'm going to have 2x squared plus x. When I move this 6 over and subtract it, I'm going to get minus 8, and that's equal to 0. And so now I'll try and factor this. I've got 2x times x. Oh, great. Looks like this might be something where we have to use a quadratic formula. I could do 2 times 4, but that's not going to give me 1. 8 times 1. Yeah, I don't think this is going to work. So I have to use the quadratic formula. So x is going to equal a negative b plus or minus the square root of b squared, which is 1, minus 4 times ac. A times c is a negative 16, all over 2a, which will be 4. And so that's going to be a negative 1 plus or minus the square root of, let's see, this will be a positive 64 plus 1, that would be 65, all over 4. So what we're going to do is we're going to get decimal numbers for that. So take my calculator. In the numerator, I've got a negative 1 plus the square root of 65. Oops. Close parenthesis and then divide that by 4. So I've got 1.766. Now, I'm going to want to remember this number, so I'm going to store this in memory. And we can do this on our TID9s as well. So I'm going to hit store alpha A. I don't know if that's really the first number I'm going to get. Actually, this is, when I do negative 1 minus the square root of 65, that should be my A value, because that'll be negative, this is positive. I'll call this B. So I'm going to store this in alpha B. Okay? Store in B. Or, my other answer is going to be I just need to change this to a negative. There it is. I get a negative 2.266. And I'm going to store that in A. So store alpha A. All right, so now when I evaluate this, I've got my exact values to work with. All right, now we need to graph these so I can see which graph is on top and which is on the bottom. So let me just draw a graph right here. Let's see. This is an upside down parabola that's been shifted up 3 units. So there's that parabola. This function, if I think y equals mx plus b, I've got a y-intercept of negative 1 and a slope of 1/2. So I'll go up 1 and over 2. All I know is that the line is going to go something like this. So these intersect right here at negative 2.266, and they intersect over here at 1.766. From the graph, I just really need to know which one's the top curve and which is the bottom curve. Now I could set up my integral. So my integral is going to go from a negative 2.266 to 1.766. I want top curve minus bottom curve. So I want the parabola minus the line. So I've got 3 minus x squared minus this line, which is going to be 1/2 x minus 1. Remember, put each of these in parentheses so that if you have to distribute something, it gets distributed to each term. Now we just need to solve that integral. Hey, so I just remembered something. I don't know if you guys remember this. In fall semester, there was one test where we got to use our graphing calculator on it, the TI-89. And I try to do one test in the spring as well. Don't freak out, we're not worried about tests right now. But in this particular chapter, I let everybody solve integrals on the calculator. Really the hard part is setting up the integral. Once you have the integral set up, we've done the difficult work, distribute a negative sign and getting terms lined up and add 1 to the exponent. That's not what we're checking right now. We're checking to see, can we find the area between two curves? So in this chapter, we can solve all integrals on the calculator. So I've gone back and I've stored my values in A and B. I know this is probably hard to see, but I'm going to go ahead and punch this integral into the calculator. So I've got the integral of 3 minus x squared minus 1/2 x. I'm going to call that 0.5x. So minus 0.5x plus 1. And I'm not going to try and simplify it any farther. I want to do that integral with respect to x, so comma x, from comma alpha a to another comma alpha b. So remember, the syntax is I want to integrate this thing right here. Then I have to say comma x, that's my dx, and then comma a, comma b. And so the answer I got for this integral was 10.918 square units. All right, so this next problem, you may not like this one too well, but it's really important. I mean, the work that we have to do in Chapter 7, we're going to have to force ourselves to think about some things slightly different. So when I just did the last problem, and I had an upside down parabola with a line going through it, when we do an integral, we have to remember what we're really doing is we're adding up a whole bunch of rectangles that fit between these two curves. And the width of that rectangle is the dx that we write in our integral problem. So when I do the integral of top minus bottom, and I put a dx in there, that dx refers to the width of each of those rectangles. Well, sometimes the rectangles don't line up the way that we want them to. Let me show you an example. If I had a problem that looked like this, where I have a sideways parabola and there's a line going through it, I can't put a rectangle right here because then when I do top curve minus bottom curve, I'm subtracting a function from itself. That doesn't work. So when that happens, we have to turn our rectangles sideways, and now this thickness becomes a dy. So what does that mean to us? Well, that means for each of these equations, I need to be able to write this as x equals something. Same thing for the parabola, x equals something. And what we're going to do, this time when we think top curve, we've got to think larger x values minus smaller x values. That's how we're going to get the length of this rectangle. This x value minus this x value. See, we're used to thinking of everything in terms of y equals. But if I did that here, I would run into trouble when I subtract this function from itself right here. All right, so let's try a problem with this. Let's say that my two equations are this. Y equals x minus 1 and y squared equals 3 minus x. Well, I want to find the area between these two curves, but this is a problem right here. Because if I want to solve for y, I could take the square root of this, but then I've got to put plus or minus in front of it. That's two equations now instead of just one. So what I want to do is I want to solve both of these for x and then try and graph those. All right, so this one, I'm going to move this y over to the side so I get y plus 1 equals x. And for this one, I'm going to move the x over to the left-hand side. I'll bring the y squared back over here. So I'm going to have x equals 3 minus y squared. And so now what we're going to do is we're going to say our two equations are going to be x equals y plus 1 and x equals 3 minus y squared. So when I look at this, I think, well, that's just a straight line. I look at this, I think that's a parabola, but it's a sideways parabola. And just like our previous example, we had 3 minus x squared. That's a parabola that opens down. Well, when it opens down, it opens in the negative direction. So when I graph this parabola, it has to open in the negative direction as well, which is this direction. If I just graph x equals y squared, that would be a parabola that goes like this. Okay? But that negative sign is going to flip it over, so now it goes this direction. And now I just need to add 3 to all the x values, which means I'll move it that way 3 units. So here's my sideways parabola. Now, when I graph this line, trying to think of slope and not y-intercept, x-intercept, it gets confusing. I'm just going to go back and graph the original function. I'm crossing the y-axis at -1, which is right here. I've got a slope of 1, which means I'll go up 1 and over 1. That means the line looks like this. And what I'm trying to do is I'm trying to find this area between the two curves. And really I just need to see this so I know which is the top curve and which is the bottom curve. So I have to think larger x values means top curve, smaller x values means bottom curve. And I can't draw my rectangle this way because I would be subtracting this curve from itself. So now we need to have rectangles that are sideways. And it means our thickness is going to be in terms of y. And so if you think about laying those rectangles side by side, they're going to go from one y value up to another y value. So I need to get those values where these two curves intersect, but I want those in terms of y. which means I need to set these two things equal to each other and solve. So y plus 1 is equal to 3 minus y squared. We'll set the whole thing equal to 0. So I'll move the y squared over here, it becomes positive. I've got that y term. When I bring the 3 over, it becomes negative, and so I get minus 2 equals 0. And then I'll factor that. So I've got y times y. This could only be 2 times 1. If I make that positive and this negative, I believe that works. Negative y plus 2y, that gives me a positive 1y in the middle. So my y values are going to be negative 2 and positive 1. So these two graphs intersect at y equals negative 2 and right here at y equals 1. That means I'm going to have an integral from negative 2 to 1. And now I need to think top curve minus bottom curve. Well, the top curve is going to be the parabola. So that's 3 minus y squared minus the bottom curve, which is the line. I got to keep everything in terms of y. So y plus 1. And then dy. There's the integral I want to solve. And so I could go ahead and maybe clean it up a little bit. I could say I've got the integral from negative 2 to 1 of a negative y squared minus y. Here I've got 3 minus 1, that would be 2. And then dy. And so now that integral, this is one we could solve on our own. We don't need a calculator. But like I said, in this chapter, I'm going to let you guys solve everything with the graphing calculator. All right, so I'm going to solve an integral. Again, I know this is hard to see, but I'll just I'm punching this right here in. I'm going to solve an integral from negative y squared, the integral of negative y squared minus y plus 2, comma, with respect to y, comma, negative 2, comma 1. And I got 9/2 for an answer, or 4.5 square units. Let me get you guys one like this to try. All right, let's try this one. I think I'm on number 4. This time I've got x equals y squared and y equals 2x minus 4. We want to find the area between these two curves. You guys go ahead and try it. All right, so I'm going to try and see what this graph looks like. If I say y equals x squared, that's just a sideways parabola. Just like if I had y equals x squared, that'd be a parabola that opens up in the positive direction. This is a parabola that opens sideways in the positive direction. And then to graph this, I'm going to think my y-intercept is negative 4, and I've got a slope of 2. So from here I'm going to go up 2 and over 1. So my line goes this way, and all that means is that the line is going to be the top curve, the parabola is going to be the bottom curve. I now need to find the points of intersection. Remember, you can pause this at any time and continue on and try things on your own, or let me go a little farther, whatever you guys want to do. Okay? So I need to find the points of intersection. That means I'm going to have to solve this for x. So I'll bring the 4 over here. That'll become y plus 4 equals 2x. And then when I divide by 2, I've got y plus 4 over 2 equals x. And so now I need to set these two things equal to each other. So y squared equals y plus 4 over 2. And I don't like to work with fractions, so I'm going to bring that 2 over here and multiply. That equals y plus 4. And then I get 2y minus 4 equals 0. Remember, you've got to set it equal to 0. And so now I'm going to try and factor. This will be 2y times y. Oh. Let's see, I don't think I'm going to be able to factor this. This is going to have to be a quadratic formula. So that means that y equals a negative b plus or minus the square root of b squared minus 4 times ac. A times c is going to be a negative 8 all over 2a. Which means I've got 1 plus or minus the square root of, this will be a positive 32, plus 1, that's 33, over 4. So I'm going to go ahead and solve this and store these values in the calculator. I'll do the subtraction part first. That'll be my a value. So I've got 1, let me put this inside parentheses. I've got 1 minus the square root of 33, close parenthesis, and then divide by 4. All right, so I got a negative 1.186. And I'm going to store that in alpha A. Okay, my second answer, if I do in parentheses 1 plus square root 33, close that off and divide that by 4, put a decimal point in there again. This time I get 1.686, and I'm going to store that in alpha B. Alright, so I know where my points of intersection are. Now I just need to set up my integral. So I've got an integral that goes from a negative 1.186 to a positive 1.686. You can just do the integral from a to b if you want. My top curve is the line, and that comes from this equation. So let's see, I'm going to write that as y over 2 plus 2, or 0.5y plus 2. There's my top curve. Minus the bottom curve, which is y squared, and then dy. There's my integral. Now I just have to get the answer. So I've got the integral. I don't really need these parentheses, but I'll go ahead and put them in there. I've got 0.5y plus 2. We'll close that parenthesis off. And then minus y squared, comma, with respect to y, from a to b. So, comma, alpha a, comma, alpha b. And the answer I got was 3.949 square units. So, I would suggest, if you find this confusing, watch it a couple of times. Take however many times you need. It's one of those things that every year people look at this and they go, that's so confusing. But after we do it a few times, it pretty soon just becomes kind of second nature. And it is an important idea. The idea of having, these rectangles that are sideways as opposed to running up and down. Not everything works that way. So, we want to make sure we get this. All right, that's what I have for you guys for today. So here's our assignment. I'm going to call this assignment number C1, C for coronavirus. So we're going to do page 452, problems 3, 6, 13, 15, 20, and 25. And that'll be it for today. I will see you guys on Wednesday.